Hello, I just wanted to make a video to give you an overview of what we've been learning in math. So we're working on with 4-digit numbers primarily, and we're doing different things with them. So the first thing we kind of started with was about representing numbers. So standard form looks like this, just regular way of writing a number. 4,327. If I want to make that into expanded form, we just divide it, we break it into chunks. 4,000 plus 300 plus 20 plus 7. And a little trickier one if it has a 0 in it. So let's say 3,021. That would look like 3,000 plus 20 plus 1. Some students will write in the 0. I don't mark it wrong because it's not really wrong, but it's unnecessary. You don't need that 0 in there. Where they can make a mistake is when they're asked to turn that into a standard number. They might see that, kind of ignore the meaning that it's 3,000 and write 321, or they won't pay close attention and that'll become 200, so it'll look like that. So those are some mistakes when you're asked to change it from expanded form to standard form. They might make a mistake because it's missing the 200th digit, or the 100th digit, I mean. But for the most part, students have a really good idea of what to do there, as long as they remember what expanded form means and what standard form means. Right now there's a big chart of paper on the wall in our classroom that shows them what it is. Base 10 blocks. So if I did 4,327, you're kind of, if you're doing it as a picture, you're kind of doing these 3D blocks for the thousands. The students have used the base 10 blocks in the classroom, and so then I would do hundreds would be 3 squares. The tens are lines, and then the ones are dots. So I would have there's 4,327. Again, they're pretty good at that as well because they've done that in grade 2 and 3 with base 10 blocks. On the test, I might give them a picture like this, although the picture will be a little bit better. It won't be me just writing cubes. It'll be a little bit better picture of that. And that's something that they're pretty good with as well. Place value chart. So again, if I take that number 4,327, we got 4,000s, 300s, 2 10s, 7 1s. One thing we did early on, which they'll see on a test or something like that, is saying like, what if I do 3,200s, 13 10s, and 6 1s? What number is that? So what they want to be able to do is see, hey, wait a minute, why we got 13 10s here? 13 10s, I can take 10 of those and make 100, so now I have 300s, and that leaves only 3 10s, so that number is 3,336. So that's something that they need to be able to do, and we practiced early on in the unit a couple weeks ago, is trading 10s for hundreds, and 1s for 10s, and vice versa. So that's representing numbers. Then something that we're going to need to practice a little bit more is rounding. So for the most part, if I ask students to round two-digit numbers to the nearest 10, so say like 37 is 40, 53 rounds down to 50, they're going to ace that. If I ask them to round 3-digit numbers to the nearest 100, say 167 rounds up to 200, 312 rounds down to 300. They're going to ace that. Same with thousands. That's going to round down to 1,000. They're going to ace that. The tricky part is we're going to give them 4-digit numbers. Something like this, and ask them to round it to the nearest 10, 100, and 1,000. And that's where we see some mistakes. That's where things start to go a little bit wonky sometimes. So we're going to practice that a little bit more. So obviously nearest 10. What sometimes students will do is their thinking is right. They say, okay, nearest 10, I'm looking at the 6, I'm looking at 56, and that's going to round to 60. So they'll write 60 as the answer. Okay. And then for 100, they'll say, okay, 56 rounds up to 100, so I'm going to write 100 as my answer. And then for thousands, they're going to say, okay, that's closer to 4,000, so they're going to write 4,000 as the answer. And that's what they're going to get. And that's a common, here is the common mistake that a lot of students make. I've been saying it a lot, I'll keep saying it. You got to include the rest of the number. So your thinking is right. When we're rounding to the nearest 10, we don't have to think about the 4. We don't have to think about the 0. We're just really thinking 56 rounded to the nearest 10 is 60. But then we got to add the rest of the number. We got to bring in that 4 and that 0. It's not 60, it's 4,060. The same thing here. The thinking is right. We're looking at 56. It either rounds down to 0 or it rounds up to 100. 56 is closer to 100, so that is correct. But we got to include the thousands digit, and that's what we want to see. So that's something that we still need a little bit of practice with, and we will. Then we had estimating sums and differences. So we use our rounding strategies to help us estimate. The idea, what I've been teaching is when you're doing an estimate, you want to just be able to do a very quick calculation in your head, something that you can do quick and fast. So we want to use our rounding strategies, but we also want to be aware of how we're changing the numbers. And so what I talk to them about is, if we look at this example, if I round this to the nearest 1,000, it rounds up to 3,000. If I round this to the nearest 1,000, it rounds down to 4,000. I'm changing this number up by about 300. I'm changing this number down by about 300. So I want to be mindful of that. That tells me that my estimate here, 3,000 plus 4,000, is going to be a really good close estimate. Okay, and that's the right answer right there. So we can see that's a good estimate. I'm pretty close to the actual exact answer, and I can do it in a matter of seconds. Here, if I use the same strategy, I'm going to round down to 3,000, and I'm going to round down to 7,000. It's going to give me an answer of 10,000. Not wrong. It's not a bad estimate, but I should be mindful that I went down about almost 500 here, and I went down almost 400 here. So I should be mindful that my estimate could be a lot closer. Maybe what I could have done instead, or what I could do after the fact, I could think of this as 3,500 and say, well, 7,000 plus 3,500 is 10,500. That gets me a little bit closer. I can also add 300 or 400 to that. Okay, because I see that's closer to 400, so maybe I want to add 400 to that and get 10,900. Add 300 to that and get that 10,800. Okay. All of these are good, but I want students to be mindful. Hey, wait a minute. Changing that to that is a pretty big difference, and changing that to that is a pretty big difference. And now I've shrunk my numbers. I just want them to be aware that because I've gone down this amount and this amount, this is going to be a little bit too low. And maybe I should do something to adjust for that. And if I bump it up to maybe that, I'm getting closer, or I can get a lot closer by doing that. So same thing with something like this. Here, if I go 5,000 minus 2,000, 3,000, I've bumped this number up by, let's say, 200. I've bumped this number down by 300. Okay. When we're adding, you want these two numbers to kind of offset. When we're subtracting, we'd rather have these two numbers move in the same direction. So this is going to lead to an estimate that's not as close as we'd like. If I change this to 5,000 minus 2,500, gives me 2,500 as an answer. That's going to be a much closer estimate. Okay, so with estimated, we want to use our ability to round numbers to get a nice, easy, fast, quick estimate, but we also want to be mindful of what we're doing to change the numbers, okay, and how close we are. Adding 4-digit numbers, students have shown that they're pretty comfortable with this. Last year in grade 3, they should have been adding 3-digit numbers, so it's really the same process. So, you know, we talk about carrying. We use base 10 blocks to show how what we're doing is really we're trading 10 tens for 100 or 10 ones for 110. So they're pretty comfortable with this. 8 plus 3 is 11. You're going to take the 1, put it there. You're going to carry 10 tens, trade it for 100. So that looks like that. 7 plus 4 is 11. Plus 1 more is 12. And 3 plus 2 is 5. Plus 1 more is 6. One thing I noticed this week is something like this. 2 plus 1 is 3. 3 plus 2 is 5. 6 plus 8 is 14. So put the 4 there. Carry the 1. When they get to here, 8 plus 5 is 13. Plus 1 more is 14. Some of them got confused about, because now I'm over 10,000 here, got confused about just putting that 14. They ended up doing like just that and not doing anything with the 1. So I'm going to kind of go over that again this week to make sure that they're comfortable with getting answers, getting sums that are over 10,000, because that's new to them. So we'll practice that a little bit more this week. But they're pretty good about adding and carrying. If you're going to practice something, I would practice subtraction more than addition, because that's definitely the thing that they're struggling more with. And that's what we'll practice more of this week. Something else we'll practice that we have practiced, because I want to make sure that when they're adding something like this, that they put it in the correct spots. So if I'm going to add this in that vertical way that we all know, I got to make sure that my hundreds digits are lined up, my ones digits are lined up. So I did see, we talked about this in class, and I caught a few students making this mistake. So we want to make sure that they're not making mistakes. So it is good practice to have these set up like this, so when they have to write them themselves, they're writing them nice and neat and organized, and they're lining up the ones with the ones, the tens with the tens, and the hundreds with the hundreds. Subtracting, okay. They're pretty good with borrowing, so they understand 2 minus 4 they can't do. Every now and then students will make a mistake where they'll say, well, it's just 4 minus 2 is 2 instead of borrowing, so we got to watch for that. 12 minus 4 is 8. Got to borrow again. 10 minus 3 is 7. And then I do a lot of practice with zeros. Okay? And that's good. You want to do a lot of practice when there's zeros involved in the thousands digit at the top, because they get confused with this. So for example, 0 minus 3 we can't do. We're going to borrow from there. That's not too different. 10 minus 3 is 7. 0 minus 5. Now I got to borrow from this 0, but I can't. So we've talked about this. We've done it the long way, where we kind of look at it like, okay, so then I'm going to borrow from here, and I'm going to trade 1,000. So now I have one of those for 10 hundreds. So now I have 10 hundreds. And then I'm going to trade one of those hundreds for 10 tens. So now I have 10 tens, and now I can do what I need to do. 10 minus 5, 5. 9 minus 6 is 3. 1 minus 1 is 0. I've also showed them, if I just rewrite this, another way to look at it is when we get to that spot. So we get here, 10 minus 3 is 7. Now I'm borrowing here. So 0 minus 5 I can't do. I need to borrow from this 0, but I can't. I need to borrow. So then I move over. I borrow from the 2. I've also shown that you could look at this because you're carrying it over. Look at that as a 20. And you're taking 1 away. You got 20 hundredths. You're taking 20 hundredths. You're taking 100 away. That's going to leave you with 19 hundredths. And now that becomes a 10. 10 minus 5 is 5. 9 minus 6 is 3. And then that's 0. Now, a lot of what's happening a little bit is students are getting used to putting 9s above 0s. And then they start doing that all the time without thinking about why or when they should. So here's an example. 6 minus 2 is 4. 9 minus 6 is 3. Here I'm at the 0. 0 minus 5 I can't do. I got to borrow from here. What's happening sometimes is they're borrowing from that, and they're just putting a 9 here, which is wrong because they're used to putting 9s when we run into this situation. And so I got to practice more with the students to make sure that they know when and why we're putting 9s above the 0, when it's turning into a 9, and not what should be here is that should become a 10. 10 minus 5 is 5. 2 minus 1 is 1. Okay, so that's kind of a common mistake that's happening. Also, I showed them a strategy the other day for something like this. Instead of doing the borrowing way, we can turn that number, 4002, and I could change it by taking 3 away. By taking 3 away, it becomes 3,999. And when I do that, that eliminates all the borrowing I'm going to have to do. So 9 minus 6 is 3. 9 minus 3 is 6. 9 minus 2 is 7. 3 minus 1 is 2. So now I have this as an answer. I have to remember to add 3 back because I took 3 away. Add 3 back and get 2,766. We call that a compensation strategy, in case you're wondering. So that is something they can do when they get stuff like this. Okay. Otherwise, the borrowing again, 2 minus 6 I can't do. So we've talked about how we can look at that as 400 and turn it into 399. And then 12 minus 6 is 6. 9 minus 3 is 6. 9 minus 2 is 7. 3 minus 1 is 2. Same as over here. Okay, so if you're practicing subtraction with your child, try to add a few examples with zeros and see how they handle that. This week, we haven't started this yet, so we'll spend a couple days on word problems. We'll be doing that a lot this week. They'll have to read the question, understand if we're subtracting or adding, and go from there. And we also been practicing mental math strategies. That's not something that I'm really going to test them on, but it's something that we're going to practice on a regular basis. So different examples of some strategies that we've done. So for something like this, there's no carrying over, so we can just quickly add the ones, add the tens digit and the ones digit. Oops, 2 plus 6 is 8. For something like this, I can see that 29 is almost 30, so I can do in my head 36 plus 30 equals 66, and then I got to take 1 away because I added 1 too many. So 66 minus 1 is 65. Or if you could really quick, you could do that all in one step and say 36 plus 29 is the same as 35 plus 30. Take 1 away from this side, add 1 to that side. Becomes pretty easy. Subtracting 52 minus 28, I might say, well, 52, 28 is close to 30, so if I do 52 minus 30, I can do that in my head. It's basically 5 minus 3 is 2, and then this 2 is going to carry over because it's 2 minus 0. And then I subtracted 2 too many, so I took 2 away that I shouldn't have. That means I got to add them back and get 24. Here, my strategy would be just to look at 6 minus 2 is 4. 4 minus 1 is 3. Do that really quickly in my head. This one, maybe what we call a jumping strategy. I'm going to turn that into 30 and 4. So I go 81 minus 30. It's just like saying 80 minus 30, or 8 minus 3 is 5. So that's 51. And then I got to subtract 4 from that. And if I need to use my fingers, I can go backwards. 50, 39, 38, 37. So those are some mental math strategies that we have practiced.